Okay, in this related problem set video, the question might be, well, but what if it's division? How does that work? So I'm going to show how to use the balancing in a division problem. One thing that makes a division problem different is that the balancing can sort of happen in two places. It can happen balancing between the quotient and one of the factors, and it can also happen balancing one side of the equation to the other side on the other side of the equals. So it's a little bit trickier, but I'll do my best here to show that. 63 divided by something is 7, or 7 times something is 63, and we'd have 9. So on this side here, we get down, we've got our basic math fact. Again, if they're stalled, it's really important. Put the 9s in first. Do as much as you can, as well as you can. Getting something written down helps your brain kind of organize what to do next. So if I've got a 3 here like this, I can ask myself this question. If I have 630 divided by 9, how can that possibly equal 7? It's got to be a larger number, doesn't it? It just doesn't make sense if it wouldn't be. And so you're kind of asking yourself, there has to be some other, there has to be like a 0 in here. These problems all involve zeros. I could put the 0 over here, 9 70s, and I could count by 70, 70, 140, and so forth, all the way up to 630. That would work. But because I don't have a blank on this side and it's staying 7, that means that this must be 90. If I had 7 90s, I could count up to 630. The balancing here takes place over the top of the division symbol. So I'm balancing 1 0 there with 1 0 there, and they cancel each other out. If I was to show you back on that scratched paper where I was demonstrating this, it's kind of like you're doing this. 63 times 10 being divided by 9 times 10. Well, if you take away one factor 10 here, you're doing the same thing to the other one, so it's sort of a fair change. There's the 63 divided by 9 is the 7. And that's why it can balance over the top of this. So that's kind of the similarity and the difference of this. Here's 6,300. Again, you got the 9 down, and there have to be extra things here. You've got 2 zeros, so this must be 2 zeros right here. Gets a little trickier when the 0 is moving across onto the other side, so I'll do this set. 49 divided by 7, 7, 7 is our basic fact here. Okay, 490, we've got a 0 here, so it has to be a 0 there because those two things balance. And you might see here, in this case, I crossed one off and put a dot. It doesn't really matter too much as long as you're really consciously thinking about counting up. And sometimes it feels more right to use a cross out, and sometimes to use a dot. Doesn't really matter to me how they do it, but this is a good way to show that you're thinking. So on this side, we've got 490 divided by 7 is 70. And you're kind of asking yourself, well, there's a 0 over here, and I can balance it with 1 0 over there. And is there any 0 that's stranded out here? Was there another 0 on this? Is there another 0 on this? And there isn't. And so that means that that's just simply the answer. And it sort of makes sense. 7 70s, if I were to count, would add up to 490, or 77s, if I were to count them, would add up to 490. So that's just how to show that sometimes it's going to balance on this side and it won't balance across that division symbol.